On the night before a launch, an engineer picked up the phone and told NASA exactly what was going to happen. He said if the seals failed, the shuttle would blow up. He wasn't guessing. He had the data. And the next morning, it happened almost exactly the way he said it would, in front of live television cameras and millions of school children watching from their classrooms. January 28, 1986. The Space Shuttle Challenger was set to launch from Kennedy Space Center in Florida, carrying 7 astronauts. This particular mission had drawn far more public attention than a typical shuttle flight because of who was on board. Krista McAuliffe, a schoolteacher from New Hampshire, selected out of over 10,000 applicants to become the first ordinary citizen sent to space as part of NASA's Teacher in Space program. Schools across the country had arranged special broadcasts so students could watch the launch live. But that morning, Florida was unusually, dangerously cold. Overnight temperatures had dropped into the high teens Fahrenheit, well below freezing, cold enough that icicles had formed on the launch tower itself. Photos from that morning show technicians spraying down ice from the structure just hours before liftoff. To understand why that cold mattered so much, you need to understand a small rubber component most people had never heard of before that day: the O-ring. The shuttle's 2 solid rocket boosters were built in segments, connected together and sealed by rubber O-rings designed to expand instantly under pressure and block scorching gases hotter than 5,000 degrees Fahrenheit, from escaping through the joints. The rubber needed to stay flexible enough to seal that gap in a fraction of a second, but engineers at Morton Thiokol, the company that manufactured the boosters, had known for months that the O-ring material became stiff and far less effective in cold weather. One of those engineers, Roger Boisioli, had put it in writing 6 months earlier. In a memo to his own company's leadership, he warned that if the O-ring problem wasn't fixed, the result could be, in his words, a catastrophe of the highest order: the loss of human life. The night before launch, with temperatures forecast to plunge into the high teens, Boisioli and several colleagues joined a conference call with NASA officials. They laid out their data. On a previous flight in January of the year before, when temperatures had only dropped to 53 degrees Fahrenheit, engineers had already found damage, a phenomenon they called blow-by, on the O-rings after the boosters were recovered. Now they were being asked to approve a launch in weather far colder than that. Boisioli and his fellow engineers recommended, clearly and directly, that the launch be delayed. NASA officials pushed back. The launch had already been postponed 5 times. There was schedule pressure, and there was the added weight of the Teacher in Space program, a high-profile mission that had already captured national attention. One NASA manager reportedly responded to the engineers' concerns by asking them to prove with certainty that the O-rings would fail. But that's not how engineering risk works. You can show that a risk has increased significantly. Proving with total certainty that a specific part will fail on a specific day before it happens is nearly impossible. Under pressure, Morton Thiokol's own management overruled their engineers. The recommendation was reversed. The launch was cleared to proceed. The next morning, January 28th at 11:38 a.m., Challenger lifted off. For the first several seconds, everything looked normal, but cameras tracking the launch would later reveal something that wasn't visible to the naked eye in real time: small puffs of dark smoke escaping from one of the joints on the right solid rocket booster. Precisely the kind of leak the engineers had warned about the night before. At around 59 seconds into the flight, a flame became visible at that same joint, growing steadily as the shuttle continued its ascent. By around 64 seconds, that flame had breached the external fuel tank. At 73 seconds after liftoff, Challenger broke apart in the sky. The shuttle's pilot, Michael Smith, was recorded saying two final words as the anomaly began. "Uh-oh." Then the transmission went silent. Millions of people, including classrooms full of children who had tuned in specifically to watch a teacher go to space, watched the explosion happen live. All 7 crew members aboard were lost. In the investigation that followed, led by a presidential commission, the cause was traced directly back to the O-ring failure the engineers had warned about the night before. The commission found that Morton Theokole's management had overridden its own engineers' recommendation, and that NASA officials had failed to properly relay the severity of those warnings up their own chain of command.